Hi, I'm Phil, and today I'm going to demonstrate the use of the Microsoft Lobe artificial intelligence program. This is the program of choice if you want to learn machine learning. And there is two other environments that I have used. One is the Jetson Nano, and the other one is the Kendrick K217 processors. Now, Microsoft Lobe is far easier to use than those other ones, and your learning will be a lot quicker. So I'm just going to walk through this mind map to explain what I've been doing. First of all, the Lobe is a machine learning software. It has an environment that I'm operating on my Windows PC to create and train models and then download the model into another device. And the one that I'm going to use is the Raspberry Pi. So what you do, you create a model, a data set, and the data set consists of lots of photos. So you put your photos into folders and give labels to those. So in my project, I'm going to sort rubbish and classify rubbish. And when I take a picture of drink cans, they'll all go into the folder called can. And that becomes one of the labels that I use in my data set. And it also becomes the model, or it becomes the classifier in my machine learning. And I do some training. That might take about half an hour or so on the Windows PC. I play with the model, see if it works, take some additional photos and see if it can classify them according to the labels that I've already created. When I'm happy with that, I then export it to the Raspberry Pi. So if we have a look at the projects I've been working on, I've had more success with the Raspberry Pi than with other computers. So I'll just show you the arrangement on my desktop. The Raspberry Pi is over here, and it's got a camera. On top of the Raspberry Pi, there's a Grove shield, and it's connected by Grove cables to various LEDs. And there's a push button that has a LED on it. And so if you want to take a picture, you just press this push button, and it will take a picture and then compare the photo against the data set, and it will use a model on the Raspberry Pi to classify the rubbish. So what we're going to do is we're going to use a published image data set of rubbish. So I'm going to borrow someone else's data set, and the next project I will create my own data set. I'm going to create a TensorFlow light model, and it will run also on the Raspberry Pi. And I want to be able to use different color LEDs to inform the user of what which bin and what classification the rubbish is. And I want to test the data. So I've got my own test data. Here's some of the pictures that I've taken. And I want to see if it labels and classifies rubbish like this correctly. So that's the objective. And looking at the hardware that I'll be using, I'm going to use a Windows PC with Microsoft Lobe on it, and it's going to it's going to create the model. That model will be downloaded into the Raspberry Pi, and I'm going to use Grove hat with Grove LEDs and a Grove LED button. and I'm going to use that to inform the user. So the software-wise, I'm going to start off with a data set, and it's someone else's model already. They've already created folders of cardboard, glass, metal, paper, plastic, and trash. So you can see they've actually taken quite a number of photos. And I want to compare my images of rubbish against the model and the data set that they initially created. So the model itself, I went to the Windows PC, and after about half an hour, it was about 82% completed. And it eventually got up to about 90. You can see the overall images after about an hour, up to about 95% of all images were completed. And at that stage, I just exported the TensorFlow Lite model and put it into my Raspberry Pi. So let's have a look at the Raspberry Pi software. And I'm going to create a Python program, and these are the instructions that I use. So we might have a look at that Python program, see if we can find it. Here it is here. And I'm going to modify a program that someone else has already done. Jean Fox has created a program to do the rubbish classification. She used a different data set. For me, just to save a bit of time, I'm going to use the published data set. But I'm going to also modify it so that my LEDs will use a slightly different configuration than the one that she used. And I'm also going to add 2 more classifications. So just very quickly walking through the model, you can see the libraries that I'm importing. And an important one is that I'm importing the image model from Lobe. So, and in addition, also the Pi camera libraries. So you can see that I'm setting up the push button. It goes on GPIO D6, and you can see the LEDs. There's 1, 2, 3, 4, 5, 6 of them. And in addition to that, there's a LED button. So there's an LED on the button, and that's used to start the camera so that it will take photos. So the classifications are here: the cardboard, glass, metal, paper, plastic, and trash. So I'm setting up an instance of the camera, and there's a routine here which takes a photo. Then I classify. There's another routine here that does the compares the label with the cardboard, and it turns on various LEDs depending on the label and the classification. So the main function just calls those functions that I've just been describing. And right at the end, I'm going to, once I take a photo, I'm going to go through another routine which prints the results. And I'm also going to print the probability of for all the labels for a particular photo that I take. Okay, so that's the program, and we can have a look at that. I'm going to use a program on the Raspberry Pi. So that program you just saw, I've now got that in Thonny Python. It's an IDE which I'm going to use to run the program. So you can see it's running now. And if I go and press the button, I can run the program. So it's going to try and run and classify. You can see I'm getting a message down here, and it's going to tell me that the current image that I've got is plastic, and it tells me the percentage of likelihood against the other labels. We might go back to the results. So overall, these are some of the images that I've compared it against, and some of them being quite good, but under different lighting conditions, you get different results. So you really need to set up a consistent environment to get this right. And we're going to have a look at so there's the overall results. So some of the pictures that I've been taking. And overall, I get about 5 out of 13 that is correct. So that could be significantly improved if I create my own data set and keep a consistency of lighting and camera conditions with the data set and the image that I'm trying to create and compare against. So overall, let's have a look at the overall critique of, here we go. Overall, I find that Microsoft Lobe, the good points are that it's free. You can work it on your Windows PC. The program works. It has no trouble at all. It's easy to use. And Microsoft have put in further improvements to the program. So I've got no bad points at all. I highly recommend that you have a look at this program. If you're interested, I've got a couple of mind maps on this, and go across to the Microsoft. The best location is the trash classifier. There's a website on that. There's a website on Lobe, and also Adafruit have an interesting Pi trash classifier. And my program was based on what they have published on their program and their project. And if you want to use a data set that's already been published, you can get one from Kaggle, and that's what I've been using in mine. But the future project, I will be creating my own data set. Okay, so that's it for time being, and I'll keep you posted on progress. This is my rubbish classifier, and you press the button and a camera takes a picture of the rubbish and tries to classify it. So the different categories are here, cardboard, and there's an LED, there's a yellow LED for cardboard, then there's glass, then there's metal, paper, then over here we have plastic and trash. So if you want to take a picture, you just press that button. And just behind the scenes, we've got the brains, which is a Raspberry Pi 3, and on top there's a hat, which is a Grove hat. So all of those LEDs and the push button are all connected by Grove cables to the Grove hat. And we've got a camera, and the camera is looking at various pictures of rubbish that I've taken, and I'm using a Microsoft Lobe AI program, and it's already created a model, a TensorFlow light model for the Raspberry Pi, and that program is working under Python at the moment. So let's have a go and see how it works. What we're going to do is just look at this image over here, and we'll press the button. So when we press the button, we get a picture on the Raspberry Pi camera, and we're just going to look to see what is the result. So it thinks it's glass, and it comes up with the percentage. So that's the first one. It's not too bad. So let's go for another image. So we'll go for a plastic bottle this time and see if it comes up. So we go back to the push button, press the push button, and we just wait for an image. There's our image on the screen, and we just wait to see what we get from that. So it thinks it's plastic. So that's, no, it thinks it's plastic, but there's the other percentage that are possible. Okay, so we might go for another image now. We've seen those two. So we've got some paper in the garbage bin, and we're going to see if we can classify that. Press the button. We've got the image on the camera, and we're just waiting for the result now. So it sees it as paper, and you can see the LED has come on to tell me that it's paper. So while it's classified it, it's also switched on the paper LED. So we might do that again, and this time we'll just watch it. So we press the button, we get the image from the camera, and we're just waiting for the classification. And there we go, the LED has illuminated for paper. Okay, so we've got 3 out of 3 so far. That's pretty good. So we might go to another one. This is cardboard now. So we'll see how that goes. We'll press the button. We get cardboard, a picture of cardboard, and we're just waiting for the result. So it thinks it's paper. So it's made a mistake there, and it's also pressed the illuminated the paper LED. So it's got one wrong there. We'll go for another cardboard. So there's a picture of cardboard this time. We'll press the button, and we get a picture from the and we'll just wait for the result. So it also thinks it's paper. And our paper LED has come back on again. So we might go for another picture. We'll do a bit of trash this time. So there's a picture we want to identify. Go to the press button. We've got our picture over here on the Raspberry Pi screen, and we'll just see what it thinks it is. And it thinks it's paper. So we've got a couple wrong there. Okay, so we might see if we could migrate. There's another one that's obviously trash, and we'll press the button. And we've got that on the screen, and we'll have a look to see what we get here. Paper, and it's illuminated the paper. So the model does have a problem. I need to make my own model and keep the lighting conditions constant. Okay, that's all for now.